So welcome YouTube. This is a response to a recent video from Antonio Subirats about the upcoming eclipse and the heliocentric model. I'm afraid Antonio can't eclipse again. He's made similar mistakes before, notably the eclipse that occurred in Chile a few years ago or recently, and he's done it again. So the main point in Antonio's video is that the moon's shadow moves from west to east, and he claims it should move from east to west. I say it's exactly as it should be in the heliocentric spheroid Earth model. So, having a little look now at whether we can produce a sort of model or an animation to show why the path of the eclipse should be from west to east rather than from east to west. So this is done rather hastily. It's not too difficult to do, but the precise geometry is quite complicated. The distances involved are very big, but this will serve our purpose. So the things to bear in mind are that we have Sun, which is, for the purposes of this situation, fixed in space. Relative to the Moon and the Earth, the Sun stays in essentially the same spot, and the Moon is orbiting the Earth in a west to east direction, and the Earth is rotating from a west to east direction. With the Moon here in grey, we have the shadow of the Moon as it's directly passing in front of the Sun from the point of view of this observer, and this observer on the Earth, and the Earth is rotating in this direction. And at the moment the observer is in the full shadow, so it's experiencing an eclipse of the Sun. Now, as the Earth rotates, the Moon is also moving in this direction at the same time, and it's actually moving quite quickly in this direction. The Moon's orbit, the radius of the orbit is about 240,000 miles, and so the orbit itself, I think, works out at 1.5 million miles, and the orbit is completed every 27 days, and so that means that the Moon is actually orbiting at over 2,000 miles an hour, and the Earth is rotating at the equator at 1,000 miles per hour. So the Moon is actually moving quite quickly in this direction, but because the Earth is covering, the rotation of the Earth is only 24,000 miles around the equator, once every 24 hours, the Moon appears to travel from east to west in the sky in the same way as the Sun does, but the Moon is traveling in this direction. So we can move the Moon a little bit in this direction, and we rotate the Earth proportionally, then we create this situation. So the Moon has moved and the Earth has moved, and we still have a shadow, and the observer is still in the shadow, but only just at this point. And the shadow has moved easterly. It's moved east from where the shadow was to where the shadow is now. And if we continue to move the Moon, the shadow continues to move, and it moves a little bit faster in an easterly direction than the observer moves. And again, we move the Moon. I haven't moved this line terribly accurately here, but the line should go to the base of the shadow here, and the Moon is continuing to move in this direction, and now our observer has moved completely out of the shadow. The shadow has moved past the observer, and is continuing on around in this direction. Now, what would happen if the moon was stationary, if the moon wasn't moving at all? If the moon wasn't moving at all, so I've taken away my arrow of direction for the moon, but we still have the arrow of rotation for the Earth. And here is our observer. And we're starting at exactly the same point as we were before. So the Earth rotates, and this shadow is in this location, in exactly the same spot it was before, and this is relative to the observer where the shadow used to be. The observer is moving in an easterly direction, and relative to the observer, the shadow is now moving in a westerly direction. And each continuing increment of rotation causes the shadow to move further away from the observer, and the moon is staying stationary, and this shadow is remaining in place. And this is what we would expect if the moon was absolutely stationary in space, but obviously the Earth's rotation was causing the moon to move across the sky. Now, the fact that we don't see this east to west progression of the shadow, what we see is a west to east progression of the shadow. This confirms that the moon is in fact orbiting the Earth in this direction and at a speed that is sufficient to cause this progression of the shadow. I suppose you could argue that that's a slightly circular argument, but what it does demonstrate is that if the moon is orbiting the Earth at the speed claimed, that is one orbit every 27.3 days, at a distance of almost 250,000 miles from the Earth, and if the Earth is rotating once every 24 hours, this is what we would expect to see. What we would also expect to see is that the moon would eventually move out of the path where the shadow fell onto the Earth. And there's always going to be a shadow from the moon. If the moon was up here, you could draw lines and there would be a shadow from the moon which simply went off into space and didn't fall onto anything. The shadow of the moon only occurs when the moon passes in front of, between the Earth and the Sun. And I expect there'll be somebody out there who'll say, well, why doesn't it happen every month then? And the answer to that is very simple. It's that the moon's orbit is not in the same plane as the Earth's orbit around the Sun. There's about a 4 or 5 degree difference, which means that only occasionally does the orbit of the moon cross the orbit of the Earth around the Sun. And when that happens to coincide, it crosses every month, but normally that crossing point does not coincide with this particular alignment. So it might happen here or here, where there is no chance for the shadow to fall onto the Earth. And when that crossing point happens to coincide with the moon, a new moon passing between the Earth and the Sun, then we have a solar eclipse. And by calculating the speed of the orbit, the rotation of the Earth, the Earth's orbit around the Sun, and factoring all these things together, we can predict incredibly accurately exactly when and where an eclipse shadow will actually fall on the Earth. And this August there is predicted to be an eclipse which will cross the United States of America from coast to coast. And this prediction is based entirely on a model of the solar system, which has the Sun roughly 93 million miles away from Earth, the Moon roughly 250,000 miles from Earth, and the Earth rotating at once every 24 hours, the Moon orbiting the Earth once every 27.3 days, and the Earth orbiting the Sun every 365.25 days. So this model accurately predicts when and where eclipses will occur. It accurately predicts the path of those eclipses, and no other model has ever been able to make similar predictions. There are claims that eclipses are easily predicted and used to be predicted many years ago simply by following patterns. Well, sort of, but not. If you mean by following patterns the calculations that I've just outlined, then you're right. If you mean they're following patterns of frequencies of eclipses and so on, then you're entirely wrong. And ancient instruments were not able to predict eclipses accurately, and the only model that accurately predicts eclipses is the heliocentric model with the spherical Earth and the Earth orbiting the Sun and the Moon orbiting the Earth. If someone comes up with a new model that can predict eclipses equally accurately, as well as predicting other things, such as sunrise, sunset, and lunar eclipses, which are when the Earth's shadow falls on the Moon, so the Moon is on the opposite side of the Earth relative to the Sun. If someone can produce a model that accurately predicts that is not based on these dimensions, then we can start to ask, well, is that a more accurate model of the solar system? But until such time as a better model is produced, this is the model that works, and it's further confirmation that the Earth is indeed a sphere. Okay, so thank you, Antonio, for highlighting once again that the heliocentric spherical Earth model is the only one that actually works.